Now let's find the distance between 2 points in a coordinate plane using Pythagorean theorem. All right, so in this example E, it gives us the point 1, 3 and 3, negative 2, and they want to know what's the distance between these 2 points. So first thing we're going to do is step 1, plot the points. So let's start with 1, 3. Remember, on a graph you start at 0, 0. 1, 3 means positive 1 means right 1, positive 3 means up 3, because the first value tells you to go left or right, and the second value, the y value, tells you to go up or down. Now we're going to plot the second point, 3, negative 2. So starting again at 0, 0, we're going to go right 3, 1, 2, 3, and negative 2 means to go down 2. So now we have our 2 points plotted. So to find the distance between these, and it's a diagonal always. That's always the distance here, so that's going to be our C, okay? So that's always a diagonal distance. So what we're going to do in order to find that distance is we're going to create a right triangle. Let me get a different color. And when you draw your right triangle, you can either do it this way or I could have done it up. It doesn't matter which way, it'll be the same. But now we've created this right angle and we have legs that we know the distance of. We know that this leg is 1, 2, 3, 4, 5 units, and we know that this leg is 1, 2 units. So now we have a right triangle. We know the legs. We are looking for this distance here, the hypotenuse. So we're going to use our Pythagorean theorem, a squared plus b squared equals c squared, to find that distance between these 2 points. So we'll have 5 squared plus 2 squared equals c squared. And we're just going to solve like we did before. So 25 plus 4 equals c squared. That gives us 29 equals c squared. So the square root of 29 is equal to c. And now I'm going to use my calculator to find the square root of 29. Which is approximately 5.38, so that'll be approximately 5.4 rounded to the nearest tenth. So the distance between these 2 points is about 5.4 units. And so this gives us a much more accurate than, you see how you can't just look over here and count, well, it's part of this and part of this one. You can't visually count with your eye, but we can get a very close, extremely close, by making that right triangle and using our Pythagorean theorem. All right, so let's do a couple more of these. Example 9, we're going to first start by plotting negative 2, 2. So start at 0, 0, left 2, rise 2, and then 5, 4 means right 5, down, up 4. 1, 2, 3, 4. So there's our 2. Oh, I plotted that first one wrong. Oh, I'm glad I saw that. Let's try this again. Negative 2 means left 2, up 2. Actually, I may have had it right. I'm just double checking. All right, so now we're going to make a right triangle between these 2 points. So I want to find this distance here. So I'm going to switch colors so you can see it a little better. I'm just going to make mine here. And then the next step is to label the side lengths, the legs. So this is, again, 2 units, and this is 1, 2, 3, 4, 5, 6, 7 units. So now I know my legs are 7 and 2, and I'm looking for my hypotenuse. So let's work it out. 7 squared plus 2 squared equals c squared. So that gives me 49 plus 4 equals c squared. 49 plus 4 is equal to 53 equals c squared. So we're going to take the square root of 53 to find c. So the square root of 53 is approximately 7.28, so that rounds to 7.3. All right, number 10, 3, 0. So starting at 0, 0, you're going to go right 3 and then up or down 0, so it's going to be on the x-axis. And then negative 4, 1 means left 4, 1, 2, 3, 4, up 1, and there's that one. All right, so we want to make our right triangle between those points. We're going to find this diagonal. Try that again. Diagonal distance. Ooh, let me erase. That was rough. Maybe I should draw my legs first and that'll help me. All right, so let me draw my legs. All right, so I'm going to go up this time. And it doesn't matter if you did it on the axis, that's fine, because it's going to end up the same. All right, so there we go. I'm looking for C. This one is 1, 2, 3, 4, 5, 6, 7 units. and this one is 1. So we're going to have 7 squared plus 1 squared equals c squared. So that'll be 49 plus 1 equals c squared. So that's 50 equals c squared. So the square root of 50 is equal to c. So square root of 50 equals, using my calculator, turn it into a decimal, 7.07. So that rounds to 7.1 approximately. So the distance between these 2 points is about 7.1 units. All right, you have 2 more left. Go ahead and try those on your own. And when you're finished, press play and go over them with me. So pause the video now and do the 11 and 12 by yourself. All right, 0, 5 means go left or right 0, up 5. And negative 2, 3 means left 2, down 3. And then we're going to make our right triangle. So this leg is 2. This leg is 1, 2, 3, 4, 5, 6, 7, 8. And we're finding our hypotenuse, which is C. All right, so 2 squared plus 8 squared equals c squared. So that's 4 plus 64 equals c squared. So 68 equals c squared. The square root of 68 equals c. And that gives me 8.24. So approximately 8.2 is the distance between these 2 points. Last problem, here we go. Negative 4, 3. So left 4, up 3. 2, 1 means right 2, up 1. All right, so there we plotted them. Let's make our right triangle. This time I'm going to go down and then over. So now I want to find this diagonal distance. That's going to be my C. So this side is 2 units, 1, 2, and this side is 1, 2, 3, 4, 5, 6 units. So we're going to have 2 squared plus 6 squared equals C squared. So that's 4 plus 36 equals C squared. Gives us a 36 plus 4 is 40 equals C squared. So the square root of 40 equals C. All right, use your calculator, the square root of 40, and turn it into a decimal. I got 6.32, so it's approximately 6.3. The distance between these 2 points, the hypotenuse, would be about 6.3 units. Hopefully you got those right. Good job.